So we're going to shine some light here, okay? And I say that the angle of incidence, so this is the ray coming in. This is my angle of incidence right here, okay? Just like we did in all those labs. Now, what's happening though, a lot of times it bounces back like this, right? And it will with our blocks that we started the lab with. It'll bounce a little bit like here. Some light will bounce back. But some light now goes through it. Whereas in a mirror, no light went through it. But here, some light's going to go through this material, this medium, okay? So, I tell you guys that the angle of incidence is 30. There it is right there. The refracted ray is 22 to the normal. Okay? Remember, this is the normal now, because this is 90 degrees from here to here, 90 degrees from here to here. Okay? What is the index of refraction for the material the light is entering? So the first thing we need to do is to write down our variables. So, theta I, so this is what you want you to write down, okay? Is going to be 30 degrees. That's a given. That's a given. Alright, so that's our theta, that's our incidence angle right here. Right there. Our theta of the refracted ray, our angle right here, this angle. When you see theta, when you see this, you think angle. Okay? That's 22. So the question is, what is the index of refraction of the material? So we want to know how much this is bending light. That's what we want to know here. That's what we're trying to figure out. Okay? We're trying to figure out how much is this medium bending the light. So, you write this down, right? You write this down, that's your question mark. That's what you want to know. So on a quiz, I'm telling you, you'll have a constructive response. Something like this, all right, is that I'll be looking for that you do all these things. Okay?
Theta R? Yeah.
R for refracted. Theta R stands for refracted.
Yeah.
Remember, the subscripts tell you just more detailed information. Okay? It tells you more detailed information. So I have all my givens. Okay? The light is coming from air. If it's coming from air, we're going to assume 1. Alright? Because light travels as fast as it can to, in a vacuum or in air. Air would be a little bit slower, but for our purposes, we don't have to calculate that precisely. Alright? So now what I'm going to do, this is Snell's law basically. Right? This is the equation right here. That's the equation. That's the equation we just copied down. If you've done this, okay, we've got one hard part to do, then it's pretty easy after this. After we just isolate the variables. Okay? After we isolate the variables. And this is why I want you guys to write down what you're looking for. So now I know what I'm trying to isolate. Now what I'm trying to get by myself. Okay? So, what you can do now, guys, is, if you feel confident, you can go ahead and try to continue on working the problem. Alright? We got to solve for, we want to isolate the variable where this is by itself. In sub r. In sub r. So we're trying to find how much this is bending the light. So we got to solve for in sub r. So what's the first thing I should do? What? Divide by what? Sine, yeah. Yes. So what you do on one side, divide by sine theta r. Yes, that's correct. What you do on one side mathematics, you have to do on the other side, right? So notice, this is what's important, guys. Don't want to mess up. This right here is going to cancel. These are not going to cancel. You see why? They're different angles. That's very important to understand. Okay? So those are going to cancel. That's going to cancel. All right? So then I just plug it in. All right? This is a 1. This is 30. And this is 22. That's your answer. Right there. Okay? So just follow your steps, write down your variables, and that's how you work this type of problem. Now what you could do is I could ask for a bunch of different things, and you could solve it for isolating for that variable I'm asking for.